So I want to go back for a minute and look at the final or the other asset account that will be a part of our inheritance tree and our interface operation, and that is the equity line. But you know what? I think I may oh, no, wait a minute. What do I want to do? Do I want to do the equity line, or do I want to do no, I'm sorry. I want to do the money market. That's in the asset group. The equity line is a credit account type, so I've got to get my notes straightened out here. And the thing that's different about the equity line is that it has to keep track of the number of charges that occur against it, because if in our setup, our imagined setup, if there are more than, what did we say, more than 3 charges in a month, then there's a fee that's applied. That's the money market. Yeah, sorry, yeah, I started off talking about equity line and that was wrong. Money market. So money market has this limit that you can only, basically withdraw a certain number of times in a time period until you have to get fees assessed. And I think that's by law. But anyway, to make this work, we're going to have to be able to post a charge. So I don't think we've done that as far as the objects are concerned. What do we have in asset? We do have the set charge in the asset. Okay, that's good. So we have set charge, set payment. So we did it on the asset account side. Do we have the capability in the form to process a charge? Let's see. So if we click charge, aha, no action performed event on my forms charge button. So that'll be our first step. Is everybody with me? Okay, so we're going to create an event to actually process a charge. And I may take some shortcuts and leave it for you to finish out. But let's see, what have I got? We want to clear the status message label. In case there's any hangover message. And there's going to be an amount field that I'll label a double. And we're going to try to pull that from the form. So in a try catch, we'll set amount equal to double, parse double of JTXT charge dot, nope, I didn't call it that. What did I call it? JTXT CHGAMT, sorry. JTXT CHGAMT dot get text. So we'll get the value out of the form, try to parse it to a double. If we are successful, we will run a set charge action using AMT and the JTXT charge description get text. So our account object, which is an asset account so far, but also potentially a savings or a money market, will process that, and we'll just double check if the get error message is empty in our account object. After that, we will set the action message. So A should have an action message in it. So we'll put that in our status at the bottom. And of course, we've just processed a charge, so we want to display values. We've got the display values down below. We're going to end up having to improve that a little bit or expand that. But we'll call display values method to fill out the form, top of the form in this case. And I'm going to go ahead and clear the input fields and reset the focus. So JTXT charge amount, set text to the empty string, JTXT charge description, set text to the empty string. All right, now if that error message wasn't empty, we came back with an error, then we just do a status message label set text using a.get error message. We want to display that on the bottom. So that should take care of it, unless of course we catch any exception E before we even get to the method calls against the object A. So that means we had a non-numeric value in the charge amount field, so we'll just indicate that. Status message label, set text, non-numeric, charge amount. Okay, and so the very last thing I will do, regardless of what transpired in the method, is I'll set the focus in the window. So JTXT charge amount request focus in window. So now we should have the ability to create an account and post a charge, at least on the asset side. Now I've got a problem in my system though, that I had created this credit account and it's throwing an error. So right now, I'm sorry? Well, it should still be unhappy because we're not implementing. Oh no, that's right. Will it allow it? I guess it'll allow it. We're implementing account, so we will add the import for account from account interface, and that cleared up the error. Huh? I would have thought it would be unhappy that we didn't implement all of the methods, but okay. I guess because credit account is abstract, it's going to let us do that. So I can clean and build. Thank you very much. That was a good solution at this point. Okay. Let's see if we can get our asset account to post a charge. So I'll run this and post it to savings and see if we've got a hit. Okay, so we're going to create a savings account. $200 initial deposit. And there we go. Now these other fields we don't need, but we'll leave them there for now. So let's see if we can post a 15 $15.99 charge for a book to the account. $15.99. That does appear to be $15.99 less than the original deposit, so it looks like it's working. Let's see if I can go out and find, let's see, 108.260. I'm going to go ahead and stop my program. Pretty soon here we're going to have to get that open existing account going for us. So, but in accounts, 108.260. So if I look at the status, savings 1, 184.01 is the balance, and I look at the log, we had a charge of $15.99 for book posted, and we had the timestamp on it. Okay, that looks all right. So I think that I can move ahead with the next type of asset account, the money market that we said we wanted to get going here. So let's see if we can make our program process that and also show how it implements the interface, but then also needs to do something a little different than the standard asset account behavior. In fact, let me take a look at savings first and see if I've got everything I need in savings. It's not very large. Oh, we're going to have a different, once we get the open existing capability in place, then we're going to want to add an overloaded constructor here, but we're okay for right now. All right, so a money market, go to your asset account package, right click, new Java class. I called mine Money MKT. I don't know why I shortened it to MKT, but it doesn't matter that much. So Money MKT as our new class. Don't forget to put your name as the author. And this one extends asset account. Because it's the asset account that is implementing the interface, and then it's the subclasses, savings and money market, which are extending asset account, and by extension need to implement any parts of the interface that asset account doesn't implement. Okay, we have our type code and type description as static constants, so public static final string type code. MM is the 2-character designation for a money market, and then public static final string type description is just that, money market. Now, every instance of a money market class is going to have to keep track of those monthly charges, and it's also going to have a count limit, a charge limit, beyond which the fee is assessed, and it's going to have to know what fee it's assessing. So we do have some private globals for the class, and I'm going to call them, the first two are integers, month charges, which is just going to be a count of the charges in the month, but then charge limit is how many charges can we have before a fee is assessed, and I'm going to set that to 3 as the default just because that's what the specification said. I think actually, legally, it might be 6, but I'm not sure about that. Okay, and then we're going to have a private double for the charge fee, which is $25 according to our program spec. Okay, so what has to happen when we instantiate a money market account? Well, public money market is the constructor. It does need to receive the name and the starting balance. It's just like a savings account in that sense. It has a name and a just default starting balance. In fact, you could even get a little fancier. Maybe I should make this an extra credit item and require a starting balance of, you know, $2,000, $2,500, $5,000, something like that, so that it rejects. Nah, we won't worry about that. We'll just let them start with anything. Okay. So what do you do in the subclass? We did it in savings. The first thing you do is you call the super class constructor. So we need to call the asset account constructor by the keyword super. But remember, we do have to send it the code. So we're going to send it money market type code. Send it to constant because that could change. So if we need to change that code, you only have to change it in one spot. Everywhere else, you just use that constant. But then NM and start val are sent. It is also the case that certainly on the beginning of a constructor or an instantiation call, the monthly charges that have so far been recorded are 0. So monthly charges 0. All right. Now we're going to have our overridden methods. So we need our public string get type code, which returns the constant money market type code, and that is an override. So go ahead and let the system add that. Come on, system. There you go. Add that annotation, and then public string get type description, return money market dot type description, and that is an override. Okay, now the question is, how do we make the money market account recognize that a charge has occurred and therefore we need to increment that monthly charge number and check it, make sure that we're not over our charge limit and therefore must charge a fee. So this isn't even an interface issue. This is really an inheritance issue. We're back to the inheritance idea. Money market is extending asset account. The charge process is in asset account, which also happens to be a part of the interface, but that it doesn't really matter in our case. Any thoughts? How we might implement this so that money market can do its extra work while letting asset account do most of the charge processing? Don't rush to answer all at once. Well, so an inheritance. you can have a subclass override, just a normal inheritance override, of a superclass method. In other words, if you want the subclass to do something special for a particular operation, you simply recode that method in the subclass. So here's what we're going to do. We're going to create a public void called setCharge, and we expect to receive the amount as a double and the string for the description. Now, it doesn't actually have to have the same variable names as the asset account, but it has the same method name. Same method name, same method type, and the important thing is the data types. The parameter types have to be the same data types, and they have to be in the same order. So we look at asset account, and we see setCharge that's a double, that takes a double and a string. And that's what we have to write here. So that, and you'll notice right away it says, hey, this is an override. Yes, even though asset account was an override because setCharge is a part of the interface, we're now writing a new setCharge for money market only. We didn't have to do this for savings. Savings just lets the regular asset account charge do its thing. But we're writing a new, so by the way, go ahead and accept the override annotation. We're writing a new method, but our method for setCharge in money market is just a little bit of extra work. The bulk of the work of setting the charge is still done by asset account. So how do we make that happen? No, you don't have to even downcast. Because we're in the subclass already, all we have to do is call the superclass. Say, hey, do this job. So here's the first call. Super.setCharge amount and description. In other words, we're going to pass through the amount and the description to the superclass, and it's going to do its setCharge thing. Now, I realize that an error might occur in that process, and it might reject the charge. But I'm not going to. I'm going to simplify this a little bit. I'm not going to worry about that. So as long as the error message is empty, I'm going to do my thing. So let me double check. So we have the possibility of an error message if something illegal happened. And we have the possibility of an error message if something went wrong with the rights. But it's an action message if the amount was less than or equal to 0. So if I'm going to charge them, in other words. So I'm going to accept that, hey, if they sent an amount through that wasn't really legal and we declined it, we're going to still count that as one of their charges. Okay, so all I need to do at this point is look for the error message in the superclass. So the money market will say, after it calls the setCharge, if super.getErrorMessage is empty, then I'm considering that it's fair game for me to increment the charges okay, so I'm going to do this dot monthly charges plus plus. So I increment that value. And if that was the fourth or following charge for the month, then I'm going to charge him the fee. So if this monthly charges is greater than the charge limit, I need to charge him the fee. But how do I charge him the fee? Well, asset account has a set charge method. And so I know that I can run it again. Super.setCharge. This time, I'm going to send the charge fee, and I just need to put a transaction description in, something like transaction fee excess charges in month. So I'm going to make use of the code that's already there in asset account to charge them the fee with the appropriate notice, and that's it. Set charge. So when set charge runs, and it is the account is a type money market, it should run this method, set charge, instead of the set charge in asset account, although savings, which doesn't rewrite the set charge, just lets asset account do it. And so the beauty of the polymorphism is that once you instantiate the object A, the account object, it knows what it is, and it'll run the methods that go with not only the superclass, but any subclass methods that have overridden the superclass methods. So this is kind of cool. I mean, this is another ooh wow moment as far as object-oriented programming goes. I hope you all appreciate. Ooh wow. Okay. There you go. So let's see if we can make the form do what it needs to do to create a money market account, because we don't have that code in place. Let me see. Yes. All right. So I'm seeing some of the code, but I'm not seeing all of my code. Where is the other code? Well, that does not appear to be in my notes. I'm going to be flying blind on this one. I think we can do it. Okay. Let's take a quick look at our creates here. So we've got to create asset, checking, say, oh, well, I didn't even put it in the, I didn't even put it in the menu list, did I? Okay, well, that's why I'm not seeing it in my notes. I must have, in the previous version, I must have left this entirely to you all, the students, but you're getting a break here. That's right, it's the checking account that we also, well, now you know how to do the checking account. So I guess I'm going to leave that one to you, but that's even easier. All right. So let's go for a menu update. I guess we haven't done that yet in this class. So if you go down to your file menu and you make sure that the little orange is around the create asset account, and then you right click, there should be an add from palette a menu item. And you choose it. So now we have a new menu item that will be, and we'll just leave it on the, it doesn't matter what order they are in the menu. So we've got JMenu item 1. Obviously we want to change the text property of that item So you can go down to the text property and change it to money market. But I think it would be a good idea to change it, change the variable name as well. So with money market selected, right-click and change variable name to JMNU MM. I think I'm using the shorthand for all of these menu items. So money market. All right. Did I do that? Yes. JMNU SV, JMNU CK. Okay. So JMNU money market. All right. Now we're going to create an event for the click of this operation. So right-click, events, action, action performed. And there you go. We've got a new MM action. They want to create a money market account. But creating an account is really just activating that top line and waiting. So we should be able to go up and grab the code that we created for the save action. We've got this set input line, so we're going to set it to true. Obviously, we're going to use the money market type code, but the account name is cleared. The starting value is still initial deposit, or the label for the starting value, and then that's cleared, and then you enable it, and the account name gets the focus. So I think we can actually grab all of that code. So highlight, Control-C, then bring it down to the MM operation, paste it in, and the only thing that will be different is that type code, which will now come from money market dot type code. But the form doesn't know about that class specifically, so we do have to add the import for asset account money market, so it knows exactly where to look. So that was the easy part. Now what happens on a create? Well, we've already got the create method started, so let's go back up there and see what we might have to do. Obviously pulling the account name and the starting value, that's still the same. But down here in our switch, where we have a case that looks for savings, we can now add a case where the type code matches money market type code. And when that is the case, we simply instantiate our account object A as a new money market using JTXT account name get text and the SV value we just pulled out of the form. Don't forget to put your break after or at the end of your case, or it'll fall through. Well, let's see. Is there anything different about our display values method as a result of processing a money market? Doesn't look like it to me. Oh, but let's make one change that I should have done this probably last week. We'll just improve things a little bit. If you look at the form, an asset account doesn't need the credit limit box, the available box, or the equity value. Those are all credit side of the house issues. All we really need is the account number, the type, and the balance. So let's make those disappear if we're creating an asset account. And to make that happen, we're going to go down to the display values method that we wrote, and we'll improve things a little bit. We'll now say, okay, we know that we always want to display the name, the account number, and the description, and the balance. So those are always true. I actually did have in my notes here, for some reason I went ahead and put available. I put the balance in the available box as well as the balance box. But I don't think that there's any reason to do that. Money market, savings, and checking. No. We'll leave it there, and then we'll say, okay, if, now we'll use our downcasting. If A, the object A, is an instance of, now the fun part is we've got several options here. We could look for an instance of asset account, or we could look for an instance of the sub-account, checking or money market or savings, because A is all of those things. But we only really need to worry about it being an asset account. So if it's an instance of an asset account, then I'm simply going to, oh, we need the import from account we haven't imported the asset account from asset account. Okay, so we'll let that import happen. Asset account dot asset account. Okay, now it's happy. We're simply going to set all of those other fields not visible. So I need to double check my labeling here. JLabel available, JTXT available. CLimit. I probably won't be able to remember this, so I'll do it one at a time. So JLabel available, set visible to false. JLabel or JTXT available, set visible to false. Then JLBL CLimit, set visible to false. JTXT CLimit, set visible false. And the last one was EQVal, EQVal, label and text. So, source code JLBL EQVal, set visible to false. JTXT EQVal, set visible to false. Okay, so as long as we're displaying values and the account object is an instance of the asset side of the house, we don't need to see those things, so we'll turn them off. And if they switch between accounts, presumably when the credit account is in play, we'll do the reverse. We'll make them all visible. Well, let's see how things play out now. Oh, yep, I can pause for a minute. Anybody need to see any other part of it at this point? I'm sorry, up a little bit. Okay, to the MM or to the create. Okay, So the yeah. Still down a little? Okay. Charge action? Okay. Yeah. So just to recap, when we run it now, we should be able to create a money market type account, an MM account, and we should be able to post charges to that account, and if we go past 3 charges, we should start seeing fees added to our operation. Oh, which makes me, well, we'll just see what happens. Okay, I'm eager to test. I'll come right back if I need to. So let's see. We run it, and now we should have a money market option on our menu. It did put MM in the type, so this is Money Market 1, $2,500 deposit, create the account. Oh, look what happened. We have an account number, we have a balance, it's a money market account, and those other unneeded fields went away. Now, Java Swing has this habit of, rolling the form up rather than just blanking out the areas, but we can live with that. Okay, money market account 1 opened. Let's do some charges. 100 for night out. And 50 for gas. And 75 for, I don't know, whatever, travel expenses. Okay, so there are our 3 charges. At this point, everything should be good. And if we've been, I haven't been following, but that should match, right? Okay, so now let's have a $275 charge for a new TV, whatever. All right, so we should be down to 2,000 when we're done, except this is our 4th charge against the money market account, and it should post a fee. And that's what it did. Charge of 25 for transaction fee, excess charges in month, posted. Now, we missed the fact that we don't see it here, that it actually charged the $275, but that's okay. I can live with that as far as the form goes. Let's see what the account itself, the log, says. And, oh, by the way, we'll do another one. So if we do a $50 charge for another dinner, this is a bad deal for us because we're only charging $50 against the account, but it should, because we're still over the limit, it should continue to charge us the fee. So yes, indeed, that $50 brought us down to $1,900. Okay, so let's take a look at our account out here. And we do have the MM. We look at the status file. It is indeed down to 1,900. That's working. We look at the log file, and there we go. Night out, gas, travel expenses, TV, and then transaction fee, dinner, another transaction fee, and that would continue. But of course now we have the issue, how do we make it stop? Because every month you roll over and you shouldn't have these transaction fees. So we ought to include some kind of logic so that it doesn't continue to charge. And that logic I will tie to the interest transaction. So we're going to assume that any interest charge process is the sign that a month has come to an end. because we're only going to be charged interest, or we're only going to earn interest at the end of a month. So whenever they click that, that's our month rollover. So we get 3 more transactions, right? So I think what that means, we're going to have to do some additional coding. Let's see. We don't have, well, in asset account, we have the set interest action logic? Yes, we do. So there's a set interest action logic, and that presumably is all good. So we need to activate that on the form. See, I'm giving you all this code as we go through it. It's so easy. Let's see. Interest action. Where are you in my notes? There we go. So let's go back to the form. We'll do that side first. So in the accounts view, an interest transaction event needs to be created. So we'll right-click, Events, Action, Action Performed. And this is going to look a whole lot like the charge action. In fact, let's see if we can even think about copying, because we're going to need to pull a single value. We're going to run the set interest action method, but we need to make sure that status display value. Okay, I think I'm going to do it. I'm going to copy all of my code out of the charge action. Maybe not the request focus in window, but the rest of it, and then I'll just change the values that I need. Okay, so copy that, Control C, move down to interest int trans action performed, paste it in, but we have to fix it. So we are going to parse double, but the field that we are parsing is called JTXT rate. Okay. So JTXT rate does the get text. And then we are going to, I'm going to take this whole thing out and let it build itself. Then the A is set interest action, and it is going to take the amount. Now, maybe I shouldn't have copied the code, because this is just a double amount. If you wanted it to be more meaningful, you could change it to rate, change it everywhere, and that's fine. You don't have to. Amount will still work. But we still want to check and see if the error message is empty. And if it is, we're going to display our values and clear, but we're not going to clear the charge amount. We're going to clear the rate field, and there's no description with this, so we can take that out. But we still need to show error message if we fail in some way, or exception message if we don't convert the rate into a double. And then we can do a JTXT rate request focus in window as our last operation. So, well, I don't know if doing a Control-C copy there got us a whole lot or not. But we now have a method in our form that will activate the interest action activity for our A object. And we can think about how a money market interest action activity is different from a regular asset account. Are we okay on that code? All right. So let's go to money market. Same principle. Whoops. Same principle applies. If we want to do something different on the interest action, then we write the method in the subclass to override the asset account. So we're going to write a public void set int action that receives a double that is the rate. And if we spell the method correctly, set int action in this case, we will get the warning that yes, indeed, we need to override, add the override annotation because we are modifying the method of the asset account class, superclass. How is it modified? Well, actually, you call the set interest action of the superclass and send it the rate, and you just let it do its thing. And I'm going to assume, I'm not going to get fancy, even if all is well, as long as there's no error. So if super.getErrorMessage is empty, as long as that's true, all I have to do is reset monthly charges. So this dot monthly charges equals 0. Set back to 0, and the count starts over, so that when we start setting charges after an interest action, it should be fine. Let's see. New money market account. Money market 2, $1,000. All right, $100 charge for A, $200 charge for B, $300 charge for C. I'm down to $400. Okay, $50 charge for D. Now I should end up getting my fee assessed because this is my fourth one. Yeah, so I went down to $350, but then a $25 fee. So now let's send ourselves a little, or make a little interest on this. So we'll do 12% interest. Dramatic. We found some great account, probably a loan shark. We're in trouble. Anyway, interest transaction at 12%. That's not right. Let's see what just happened. And if I do a $50 E, okay, well that's working. So it appears that my problem is that my interest rate on a money market account is not earning interest. It's charging me interest, which is not what should be happening on a money market. So, oops, I apologize, because that's the code we did last week. I guess we didn't fix that. I just brought it over from the card.java. Let's see what's happening here. Okay, so if we go to asset account, and we look at the set interest action, what is it doing? All right, it checks to see that the account is active. It checks for the interest rate being between 0 and 1, interest rate of decline because it's out of bounds. All right, interest charge equals this. Yeah, okay, so here was our problem. Interest charge is not an interest charge necessarily, but it's not an interest charge at all on an asset account. Okay, so I'm going to rename this value. Instead of interest charge, we'll call it interest earn. Interest earn equals the balance times the rate divided by 12. But then we don't set a charge because that's going to subtract. So we're going to have to set a payment, and it won't be clear that the interest, that it was a payment for interest. So unfortunately, I guess we're going to have to rewrite our own. We're going to have to write our own code here. Let's go up to the set charge or set payment. We can grab it here. Well, now we'll go up to the charge. Okay, so in a set charge operation, once we have determined that all is well, we're going to add the earnings to the balance and then write the log. Okay, so let's grab this bit of code and go down to our set interest action. All right, so I'm going to take this out, and the balance has to be plus the interest earned, int earned, and then we'll write the status, and then if the error message is empty, we'll say interest of int earn for interest earned. Let's come down here. Or we'll just say interest earned and we'll add the rate at rate of, we'll say at annual rate of IR. Oh, but then we need a percent formatter. Okay, we'll do it. But don't forget on your bottom line of code that if you have to back that out, you subtract the interest earned. Okay. Well, all of these little things. Okay, I'll just leave it. No, I won't. Let's do a percent form. Oh, we have a percent formatter. So we have a P. Okay, I don't know why we. Oh, there's our action message. Wait a minute, what's going on? Oh, interest. Oh, rate of. Okay, that was declined. All right. Okay, so down here we can do P dot format of IR. Okay. We've already had that set up above. So this is the code I want in my interest action for the asset account class. Let's see if I've gotten all of my bugs cleaned up. All right. And I should probably do another test run, but I'm fairly comfortable with this now, and I'll test it without having to put it on the recording. Because if we go out and look at that money market account that we just built, the log was correct. We had all these transactions. The last one caused a fee. Then we had interest earned, although it subtracted it instead of adding it. So we have to. That's what we fixed. And it caused an extra fee to happen because it wasn't recognized as a payment balance. So maybe we do need to test it. Okay, so we're gonna let's build again. We'll run. Okay, so a new account, real quick. Then we'll take our break. Money Market 3, another $1,000 account. All right, so 100 for A, 100 for B, 100 for C. All right, now this is 100 for D, so it should take us down to 600, but then the fee should apply. All right, so 575 looks good. Now we'll try to earn some interest, so it should be $5.75, I guess. Interest earned. Interest of 575 earned, so in fact that at annual rate of 12%. Okay, and then if we do another $100 for E, we should only see the balance go down to 480.75 because we posted transaction. Okay, now I think we're working correctly. So what I would like you to do, as we take our break, and then I'll give you a little extra time, I want you to see what you can do with the checking account on the asset side. Remember that a checking account is just like a savings account. Remember, there's not much in the savings account. Just like a checking account, just like a savings account, except checking doesn't earn interest. So an interest action should not be allowed against the checking.java class. So we've paved the way for you. See what you can do with that after a break. Yeah. Oh, in the asset account? Yeah. Whoops. So So this is what we changed in that set interest action. So I'll leave it here for you. So you've had a chance to work on your checking account, and we'll pursue that a little bit and then make our form work properly. So if we ask for a new Java class in the asset account group and call it checking.java, and we compare it to savings, well, we didn't extend asset account, but we're still going to have obviously the static finals. We're still going to need to call the super class with the proper declaration, send these. So as a structure, this is what we need. So let's go to checking and make that happen. So we're going to extends asset account. And we've got public static final string type code equals CK. Thank you. Was blanking out there for a moment. Public static final string type description equals checking account. A constructor. So public checking. Oops, what do we have to receive? We receive string name double as start balance. Very good. And we call the super class, but we send it, of course, the checking type code, and then the name, and then the start val. I'm sorry? Yeah, any name you choose for your parameters is fine. Doesn't have to match mine exactly. sval is good. Okay, and then we know that we have to have our public string get type code method that returns the checking dot type code constant, and public string get type description that returns checking dot type description. And those are both overloaded, so we'll let it add the annotations to those. So we're in good shape up to a point, except that this checking account at this moment will operate exactly like a savings account. So how do we stop it from acting like a savings account? Anybody have a recommendation? Even if you don't have the exact code, what's the general approach? Well, you're thinking on the form side. No, I wouldn't do it that way, because you have to. I don't think the form is the place to address the issue, because if somebody else wrote a different form or a web page, they might accidentally get into, not know to control that way. So if we put the control in the asset account, anybody have another suggestion about an approach we might take? Think like the money market. Well, we're still getting our feet wet on all of these object-oriented principles, so that's okay. I won't think too terribly of you. What do we have to go ahead? Yes, there you go. We have a winner. You need to override the set interest action and prevent it from running the asset account's set interest action. Exactly. So what I will do is have a public void set int action. Now this, whoops, did I not name it correctly? What did I call it? I thought it was set int action. Set int action. Oh, it receives I know why. It's there. That's a good point to make. It receives the double for the interest rate. Okay, so the checking account, the reason I wasn't seeing an override message here is that this set int action is actually not the same as the set int action in asset account, because that one expects a double, and so we need to expect a double for the rate. And now it says, okay, you're trying to override the interest action. So yes, we are. But here, we don't want to run the super set interest action. So we just ignore it. But we probably ought to put a message that, hey, they tried to do something that's not allowed. And so what I propose is that we create a message, a string. So we're going to have a string. Well, let's see. Wait a minute. Let me go back and look at asset account. So if we were running that in the asset account, how would we do it? We would set an action message that says, hey, we're declining because the account doesn't earn interest. And then we would write the log for that message, and we'd be done. That's all we'd have to do. So, but we would like to have the action message come back out on the form. So we really are wanting to do two things. We're wanting to set the action message in the superclass and cause it to write the log with that action message. We do not, at present, have any such method for setting the action message. We've got all these set charge, get action messages, get balances, get error messages, okay? But we don't have anything for setting the action message so that a sub-account, a subclass rather, can make that. So how would we create, here's another pop quiz for you. Remember, we've got that assessment coming in a couple of weeks, so that's assuming that the country lives through the Armageddon of November 8th. Anyway, yeah, what happens right after, the day after, exactly. Okay, so, pop quiz. How can we allow a subclass to make a change to a value in the superclass that's currently private, but we don't want anyone else except a subclass to be able to do that. Anybody remember our technique? I realize I think we only did it one time. Here's what we're going to do. We're going to make another method to set the action message, but it's not public because then anyone could get to it. It's protected. Protected void set action message receiving a string for the message. Now, we're doing this in the asset account level. So we're making it possible by a protected method to have the subclass set a value. And what we do is we set this action message equal to whatever message came in. Now, we also can assume that if the subclass is using this method to set an action message, we should probably write that to the log. So I'm going to do both actions with this one step. So I'm just going to put a little note. If action message is set from subclass, update the log file. And so that'll allow us to say, all right, let's do a write log of message. Well, you know what? We ought to be a little careful. If message is not empty, so we'll do a not is empty call. So if the message is not empty, then we'll go ahead and write the log. If they went to the trouble of sending us an empty action message, shame on them. We're going to ignore it. Okay, so now with this protected method in place, we'll go back to checking, and we don't even really need to create a string. We can just call directly on a set interest action. We're not calling the super set interest action. We're doing one thing. We're going to do super, whoops, hit the caps lock, super dot set action message, and the message is interest requested on non-interest bearing account. So that's kind of a long message, but there you go. And that's all we really have to do. We've changed the behavior of the interest process for a checking account. Of course, now we need to have our form be able to create a checking account so we can test. So we'll go back to Accounts View and finally write an event for the checking. So go to your menu, click Checking, and Events, Action, Action Performed. The good news here on the CK Action Performed event, of course, is that it's virtually identical to MM or SV that we've already done. So let's just grab code out of the MM action and bring it down. And then what has to change? Well, the type code changes to checking type code, but we don't have the import yet, so we've got to go over there and say, oh yeah, asset account.checking needs to be brought in. Initial deposit, still the same on a checking account, so that's good. Everything else looks okay. So we've got the line ready to go. What does the create have to do? Exactly. So up here on the JButton create, still pulling the values. It's still an asset account, so everything is almost the same except we have a new case where checking type code is the match on the top line, and we do an A equals new checking, sending it the account name, get text, and the starting value. And then we break after that case, and I think that's it. I think we're ready to test. All right, let's see what happens. So file, checking account, CK is in place, checking account 1, initial deposit 250, we create, there's our account, checking account 250, looks good. We'll make a charge of 25 for food, brings us down to 225, and then we say, all right, I want some of that 12% interest that we haven't seen in 50 years. Let's try to have an interest transaction. Interest requested on non-interest bearing account. Let's see if that got into the log. So we've got a checking account here now, 225, that looks good. And checking account, charge 25, interest requested on non-interest bearing account. Isn't that lovely? I hope it's sort of beginning to be partially clear how this inheritance business and the overriding of methods and the polymorphism with the superclass and now with an interface thrown in, how it all sort of is coming together. We'll do it again in the next assignment. Of course, we've got a lot left to do on this assignment, and we do have a few minutes. I want to see if I can get one more thing in place, and that is the reopening of an existing account. So this is going to require us to recall some code that we wrote in Java 1. If you had me, we did this once or twice in Java 1. Of course, I have to be able to find. There we go. Open. Okay, so we've got in our menus all these creates, but we also have an open existing account option. And for this to happen, I want us to have the program pop up a file chooser so that the user can see all of the different type files, choose one of them, and have that account be reopened. So let's create a method, an event method, on our JMenu open menu option. So action, events, action, action performed. Menu open. The account number is an integer, and so we're going to need one of those. So account number. Oh, and you know, I probably ought to. Well, I'll create the variables first. Okay, so we've got an an integer account number, a string for the file name that they choose, and then I'm going to have a type code. I'm going to extract that because I'm going to have a similar kind of operation after I figure out what type they're using. So now we can do a status message label, set text to the empty string. I also don't want the input line, so I'm just going to make sure that the set input line is false, that that's been turned off. So if, in other words, if they, and we really should have considered this all around, but I'm not going to worry too much about it. Right now, the way the program's written, it's possible for them to start a creation of an account, and instead of clicking cancel, go up to some other menu and try to create a new account, a different account. And I'm not sure what exactly would happen in our program. We need to think about that. But at least if they go from a creation line entry to open an existing, we're going to turn off that line, which is a way of canceling it. Okay, so here come the objects that we need. JFileChooser. F is a new JFileChooser. And this will require an import. And then we will set the dialog title to be select account file. And then we're going to filter on text files. So I'll go ahead and do it. File name extension filter. This is that weird long thing we've got to set. This is our filter, and it'll be equal to a new file name extension filter. And the filter says text files star.txt. But what we need to remember in the Java world is that the second entry, the actual filter, doesn't take the dot. All you do is txt as the actual filter, and it'll filter after the dot on the file name. But we need our import for file name extension filter. Okay, so we've got one of those. Now we're going to apply it to our file chooser. So f dot set file filter to filter. And then we need a dialog window. So we have to create JDialog DG as a new JDialog. But this is the weird kind of reverse business where we actually open the file chooser by telling it, okay, file chooser, show your dialog and use this dialog object as your container. So we're going to have a return val. Remember that on file choosers, if you've done this before, have a return val that we need to look for in case they ask for a cancel. So our val, return val, will be equal to f dot. We want to do the show open dialog. We're trying to open a file, and DG is the container. So there's your line that actually pauses the program and pops the dialog up. So the file chooser comes up as an open dialog inside the DG container that we just created in code. A return value comes back, and we can investigate. So if our val is equal to a JFileChooser constant that is cancel option, then they canceled rather than selecting. So we'll just do status message label set text open action canceled. But if they didn't open, then we're ready to process. We have a file name of some sort. So file name equals f dot get selected file. Notice you can have an array of files or a single file. So we're only letting them open one account. So we're going to get selected file. And in particular, we're going to get the name of that file. So FLNM, our string, now has just the name, not the full path, just the name of the file. Okay, well, now we've got some processing issues, and I'm going to leave some of this to you. At least I'd like to leave it for a while for you to see if you can work out the problems. But what we are going to assume is that the first two characters are a type code. So I'm going to set type code equal to the file name dot substring, and we want to start at 0, and we want to go 0 and 1. We want to pull the first 2 positions of the file name as the type code. But this is the weird, remember the substring is the weird thing where you have the starting position and then the ending position, but not including that number. So we're actually going to put a 2 here. And while we're at it, let's just do a 2 uppercase. So we're sure it's in the form we expect. So that says go to 0, 1, and 2, but don't include 2, just give me 0 and 1. So we get our 2 characters into the type code. Now the question is, how do we get the account number? Well, I'm going to give you one approach which is going to work, but it's incomplete. We'll say it's incomplete. We're going to assume that if we got the 2-letter type code, that the account number starts after that. So it actually starts in position 2. And so I'm going to create, did I give myself a, I did give myself a variable, didn't I? Account, yeah, account number. Okay, so account number will be, oh, I should do this in a try-catch, shouldn't I? Well, yeah. We'll put a try-catch right inside the else. Make it really complicated. Don't you love this program? It's so fun. It's such a little bit of detail here. Okay, so account number will be equal to integer parse int of, okay, what am I doing? I'm parsing the int of FLNM dot substring, and I want to start this time at one specific spot, substring at spot 2. But I have a problem. You knew there'd be a problem. The problem is that I've got .txt at the end of all my files. So if I try to parse an int from position 2 on, it's going to blow up when it gets to the .txt and won't parse it as an int. But what I can do is I can do a dot on my substring and say that I want to replace .txt with empty string. So now I should have the integer, which is the correct extraction of an account file that has the 2-character code at the beginning and starts with the account number after that. So what am I missing? Well, we've got the log files out there. So some of our files have a 2-character account or 2-character type code on them, but an L in in position 2 instead of the start of the account number. So the way you need to improve this method is to write it so that they can choose a log file. If they accidentally do that, we still will extract and open the account. So just put a little note. Final version needs to handle log file selection as well. Okay. I tell you what, let's just do on our catch. If we catch a number format exception E, we're going to abort the process basically and say, all right, status message label, set text, no account number found. And then we'll return right at that point. So if we get this far, we are pretty sure we have a type code and an account number. So we have what we need to correctly instantiate our A object, right? And we're going to do it with the same kind of structure. We're just going to plug it in here. That also suggests that maybe we should write a more generalized method, but that's okay. We're going to switch on the type code, lowercase type code, that we pulled from the file, and we're going to do our three cases that we know about so far. So if we have a savings type code, doesn't matter what order you do them in, then A is a new savings account, sending it what? Well, we're going to have a different constructor. We're going to have an overloaded constructor because the only thing we need to send it is the account number. So none of these constructors are going to exist yet. But if we have checking type code as our match, then A is a new checking account that receives the account number. And the case where we have a money market type code, which is the only ones we can figure out how to do right now, then we have a new money market, and we send it the account number. It should be able to do the rest. And our default here is status message label, set text, unknown account, unknown account type. Okay. Now, is there anything else? Yes, of course there is. After we're done with the instantiation, this is the end of the switch, then we need to see if all is well. So if A, get error message, is empty, then the instantiation call above us worked, and we can display values. We've got that method available to us, and we'll do a status message label set text of A dot get the action message. But if the error message was not empty, then we have to display, we do a status message label set text to A dot the error message. Okay. So that's a whole lot of stuff on the form side, and I realize that you probably need me to go back. But all of the three errors showing say, hey, constructor cannot be applied because I expect a constructor that takes a string and a double, and you're trying to send me an int. Well, let's see if asset account has the code we need. I don't remember whether I put it in or not. So if we look at the asset account, constructor, do I have only one constructor? Oh, I have only one constructor. I have a constructor in asset account that takes just the starting values. I need the constructor that takes just an account number. So if we go back to card.java, there is such a constructor. Int A. But of course, it's going to need the type code now as well as the account. But once it has the type code and the account number, it should be able to do its work. So let's grab from card.java the constructor that is the overloaded constructor that expects the account number. So I'm going to do Control-C, and I'm going to go back to asset account. Oh, you know what? Let's take that back. Let's take only the insides. Let's start not with the declaration, but just the inside. So Control-C on that code. We'll go back to asset account, and now right here, we're going to have public asset account that receives type code, string TC, presumably it can get the name out of the status file. So all it needs after that is integer A, and we'll paste in our code and see what we've got. Okay, so an asset account doesn't have a credit limit, so that line can come out. And we change the name of our balance to balance instead of baldo. We still have account number. So error message empty, action message emptied, balance is set to 0, account number is set to A, and then we try a buffered reader, but not CC. It's going to be TC plus account number plus .txt. And if we're successful, we will read the first line. So we'll read the name, the NM variable, as not a parse double, but just as an in.readline. So the first line should be the name of the account. The second line is the balance, and that we do need to parse into a double. But assuming that works, we close the input file, account A was reopened. Otherwise, we have error reopening account, and we set it to -1, and our balances stay at 0 and so forth. But that should do it. Now this constructor doesn't write anything to the log when it reopens an account. So that's a debatable issue. I'm just going to keep that as an action message and not have to put a log entry that says, oh, you went away and you reopened me. We'll just leave it at this. So this is the overloaded constructor in asset account. Now we need each of the subclasses to be able to use this account. And that's going to be pretty simple, right? So if we go back to each of our accounts, we'll start with checking. Checking has a constructor that takes a name and a start val. Now it's going to have public checking that receives only an int for the account number. And what is it going to do? It's going to do a call to the super constructor, and it's going to send checking.typecode and account A. And that should be all it needs. Money market, same deal. We have a constructor that calls the super. So we're going to have an overloaded one, public money market. Integer A comes in. Super constructor is called, and you send it money market type code and A. Now you have a decision to make, because if you reopen an account, you don't really have a way of knowing for sure where to start the monthly charges, how, because they might close and reopen. For this simple approach, I'm just going to assume that monthly charges are 0. If they've closed and they've gone away and come back, we're going to assume it's a new month. We'd have to get a lot fancier to otherwise. Well, a little bit fancier. Okay. Money market. Same thing on savings. Public savings constructor that receives just an integer A, calls a superclass, sending it savings, type code, and the A. I know that was a lot to take in a very short time because I was racing along. If you need code back on the screen after we're done testing, that's fine. Let me just do a quick test and see if I can, in fact, reopen one of my accounts. Let me check a balance. If I reopen my checking account, it has a 225 current balance. So let's see if I can grab that one. So I'm going to run, do a file, open existing account. It brought me up, but it brought me up in a location that I don't really like. It kind of surprises me. So I need to let's set a starting value on the file chooser. I didn't do that. So in the accounts view, file chooser, we can set quote dot quote, which is the Linux way of saying current directory. So I think that's how we do it. So I'll do a file, open existing account. There we go. There, now I see him. So I'm going to try to open this checking account, and answer is checking account 1 came back with a balance of 225. Let's do it again. Open existing account for the money market. I don't know well, let's do the savings, one of the savings accounts. I remember that is a valid number, but if we try to do an open existing account and we accidentally choose a log file, no account number found. So it left the old one. We should probably clear that out and so forth. But anyway, I think we've got the guts of the operation in place. So for next week, we really will be back to the credit account, which I had asked you to work on this week. So do what you can, continue to do what you can with the credit account, and we will get to a certain point, and then I will turn a little bit of it over to you to finish up. But we're there. Yeah, let me for those who are on the recording, let me just review what we've done so far. So in the view program, we built the open action performed, which looks like this, uses the file chooser, then extracts the file information from the file that they select, and then it instantiates based on the type code that it finds. Then we had to write in asset account an overloaded constructor that makes use of that account number, and it also has to know the type code. And then in each of the subfiles, we simply had to write an instantiation call, a constructor that takes the account and then sends to the superclass the necessary information. So again, that's a lot of coding in a night. We did a lot last week, we've done a lot more tonight, and we're still not done with this silly thing. But we'll get there next week.